Reinforcement learning rewards should be denser, right? Reward the agent for every tool call, every partial step, not just the final outcome. Intuition says more signal means faster learning. A 2026 paper on multi-turn reinforcement learning for tool calling agents proves the opposite. On a realistic airline customer service benchmark, dense per turn rewards catastrophically degrade performance by up to 14 percentage points. Not because the reward values are wrong, but because of a subtle math bug in how the advantage is computed. The fix is not better rewards, it is calibrating rewards to the data. Here is why your intuition is backwards. The bug is called advantage misalignment. Take a read-only turn, like the agent looking up a flight. You reward it plus 0.3. That produces a small positive per turn advantage that says, reinforce this. But the outcome advantage, the much larger signal from whether the task ultimately succeeded, points the other way. Add them together and the read-only turn gets suppressed, the exact opposite of what you intended. The numbers are brutal. Reinforce plus 0.05, suppress minus 0.65, 27.5% of all turns are dead, zero gradient either way. Your reasonable intuition is actively training the agent to do the wrong thing. The paper's first fix is a hybrid advantage. Borrow discounted returns from a method called GTPO, gamma 0.9, then dampen the outcome advantage with lambda 0.3. Discounting naturally weakens the outcome's pull on early turns, while the dampened signal keeps a correctly directed nudge. Result, 0 advantage mismatches, down from 2, and dead turns collapse from 11% to 1.4. The learning signal now points the right way on every single turn. Then the headline. After full training, a 4 billion parameter Qwen model hits 66.7% on the benchmark. That beats GPT 4.1 at 49.4 and GPT 4o at 42.8, despite being roughly 50 times smaller. Scale up to a 30 billion mixture of experts and you reach 69.5%, nipping at Claude Sonnet 4.5 at 70. The calibrated 4 billion model beats frontier closed models. The calibrated open 30 billion nearly matches them. So how do you set the reward values? The paper's signature method, iterative reward calibration, measures each reward tier's actual correlation with success. Gold exact actions correlate at plus 67, keep them at 1.0, errors correlate at minus 76, keep them negative, but read-only turns correlate at essentially 0, plus 0.1. They carry no information about whether the task will succeed, so the calibration loop zeroes their reward. Reward values become proportional to discriminative power, not to your guess. 2 or 3 iterations and the misalignment is gone. Picture what dense rewards do to the learning signal. They scatter it. Every read-only lookup, every chatty confirmation gets a sprinkle of gradient, diluting the signal across dozens of turns that do not decide anything. Now picture the calibrated signal. It focuses. Every drop of gradient lands on the few gold action turns that actually separate success from failure. Sparse rewards are not lazy. They are accidentally perfect, concentrating 86% of the live gradient exactly where it matters. The dead turn collapse is the cleanest proof. Under the hybrid advantage, dead turns with zero learning signal across all rollouts, drop from 11% down to 1.4. The agent is no longer wasting training capacity on positions where every rollout behaves identically, and dead turns are not noise to remove. They are the routine scaffolding, the polite lookups and acknowledgements that naturally sit between the decisions that matter. Focus the gradient on the decisions and the scaffolding takes care of itself. And it shows up in real conversations. On a social engineering task where the user flatters the agent to break policy, the untrained base model spirals, 56 turns over 27 minutes, calls the wrong tools, scores 0 for 2 on action accuracy. The trained agent cuts that to 28 turns, about 10 minutes, nails both actions and ignores the flattery entirely. Half the turns, 65% faster, 100% accuracy, plus manipulation resistance. Calibrated rewards do not just raise a number, they change how the agent behaves under pressure. Dense per turn rewards, designed with reasonable intuition, actively hurt tool calling agents up to 14 points. The fix is calibration, not more reward. Measure each tier's correlation with success. 0, the non-discriminative ones, dampen the outcome advantage and discount the returns. Result, 0 misaligned gradients, dead turns from 11 to 1.4% and a 4 billion parameter open model beating GPT 4.1. The paper is multi-turn reinforcement learning with iterative reward calibration. Reward values should track discriminative power, never intuition. Subscribe for the next breakdown.